Welcome to day 2 of distance learning, Northmont. Today's topic, electronegativity and bond polarity. All right, I know we've already talked about electronegativity. The Greek symbol is the letter chi. I like to kind of write it like an X with a little tail on the upper left side. Basically, it's the tendency of atoms to attract electrons when forming bonds, or how electron greedy an atom might be. If you look at the periodic table, you'll notice that the range is from about zero point 0.7 up to about 4. And I can even go down and show you real quick. By no means is this a complete list, but your lowest values are going to be in this corner, and then fluorine will be your highest value. You'll also notice that noble gases have been omitted because they don't tend to form bonds. All right, now what we're going to do today is we're going to determine if something is ionic or covalent. So this little chart right here is going to help you decide what it is. Now, if something lands on kind of one of the transitions from one category to the next, don't panic. It's really just a way of categorizing things. So a couple examples. We'll start with an easy one. Hydrogen molecule. So hydrogen is bonded to hydrogen with a single covalent bond. And what we want to do is we want to find the difference in electronegativity. So in this case, I know that hydrogen is about a 2.1. So if I do some simple math, 2.1 minus 2.1 is 0. So the difference in electronegativity for hydrogen is 0, in which case hydrogen would be pure covalent, or we could say that it is nonpolar. All right, let's do another example here. Let's do hydrogen bromide. So hydrogen connected to bromine by a single covalent bond. I'm pulling the electronegativities from memory. I could be off a little bit. I do believe that bromine is about a 2.8. So we look at the difference here. I always take the bigger number first. So 2.8 for bromine minus 2.1 for hydrogen, a difference of 0.7, and that would put us in the category of slightly polar. So hydrogen bromide would be a slightly polar covalent compound. Now let's look at some other examples. What about something like silicon oxide? Silicon is a metalloid, and oxygen is a nonmetal, and this is a bond that forms in glass. So we say, okay, is this ionic or is this covalent? So I guess we need the electronegativities. Oxygen is going to be higher. Oxygen is at a 3.5. Silicon is at a 1.8. And if we look at the difference between those, a difference of 1.7 tells us that this is a very polar bond, but still falls into the range of being covalent. Okay, one more example before we get to this last part, and let's pick something that we know to be purely ionic, sodium chloride. So we take the electronegativity of sodium, 0.9, the electronegativity of chlorine is a 3, and the difference between those is a 2.1. I didn't show my math that time, but if you look at my chart, anything above about a 1.8 is going to be considered to be ionic. So sodium chloride, we all know to be an ionic compound. All right, last thing that you're supposed to do down here is you're supposed to rank the following from least polar to most polar. So I have a list of, it appears to be 5 different substances, and we have to rank these from least polar to most polar. My formatting's off a little bit, but we'll do this anyways. All right, so hydrogen bonded to hydrogen, 2.1 minus 2.1 is a 0. So 0 will be completely nonpolar, and this is going to be the least polar. All right, when we start to do some math, sulfur bonded to hydrogen, we have a difference of 0.4. Chlorine bonded to hydrogen, a difference of 0.9. Oxygen bonded to hydrogen is a 1.4, and fluorine bonded to hydrogen is a 1.9. So I've actually already put them in order for you. Some simple math will tell you which one is the most polar, which one is the least polar, and these electronegativities are useful in predicting bond character as well as nature of polarity. And we all know when we talked about solutions that polarity has a lot to do with how things dissolve in water. All right, thank you guys for listening. The assignment is posted in Google Classroom. I miss you guys. I love you guys. I'll see you soon.